Hello friends, today we're going to talk about how we can prove that two triangles are similar. Prior to this, we needed to show that all three sides of one triangle were proportional to all three sides of the other triangle, and that all three angles of one triangle were congruent to all three angles of another triangle. Today we're going to learn about some shortcuts, so we don't have to show all 6 of those things to show that two triangles are similar. So we can use AA, SSS, and SAS to prove triangles are similar. We're going to construct logical arguments based on definitions and theorems to prove triangles are similar. So recall, earlier in this unit, to show that these two triangles were similar, we had to show that the sides were proportional. So that means we had to show that side AB over side DE was equal to side BC over side EF and side AC over side DF. So if we plug in the numbers here, AB is 32, DE is 40. If we simplify that, we would get 0.8. BC is 24. EF is 30. If we simplify that, we would get 0.8. And then AC is 36. And DF is 45. And if we simplify that, we would get 0.8. So I know that all of the sides are proportional. If we look at the angles here, I know angle A is congruent to angle D because they're both 40. I know angle C is congruent to angle F because they're both 60. Well, if they both have two angles that are 40 and they both have two angles that are 60, that means the last angle for both of them has to be 80 degrees. So then I know that angle B is congruent to angle E. So yes, triangle ABC is similar to triangle DEF. So that was a lot to show. Now we're only going to need to show 2 or 3 of these things based on which theorem we're using. The first one we're going to look at is the angle-angle similarity theorem, which says if 2 angles of one triangle are congruent to 2 angles of another triangle, then the triangles are similar. So looking up here, without having to do all of this work, all I really needed to know that these 2 angles were congruent to say that the 2 triangles were similar. So let's look here. Triangle ABC has angles whose measures are 61 and 60. Triangle DEF has angles whose measures are 65 and 60. Are they similar? Well, here we know that all 3 angles need to add to 180 degrees. So I know that X plus 61 plus 60 is 180. If I solve for X there, I would get that the last angle is 59 degrees. So we don't know which angles are 61, 60, and 59. I'm just going to put the numbers in here. We'll say that's 61, that's 60, and that's 59. And then for our other triangle here, X and 65 and 60 has to be 180. And if we solve that, we would get X is 55 degrees. So we'll say this is 65 degrees, 60 degrees, and 55 degrees. Since I only have one pair of angles that are congruent here, no, these are not similar because there's only one set of angles that is congruent. We need 2 sets of angles that are congruent. So here, they're telling me that angle A and angle R are the same. They're also telling me that angle B and angle S are the same. And we see here that A and R correspond to each other. B and S correspond to each other. So since we have 2 pairs of congruent angles, yes, they are similar. We can say they are similar by AA. That means angle, angle. This next one, we have A congruent to R. We have C congruent to T, which we don't need to say this, but we automatically know then that B and S are congruent. So since we have two pairs of congruent angles, we can say that triangle ABC is similar to triangle. You have to make sure that you line up the letters. So since A and R are the same, R will come first. B and S are the same, so S will come second. C and T are the same, so T will come third. So they are similar by angle. Triangle ABC has angles who are 59 and 62. So I'm just going to say this is 59 and this is 62. Triangle DEF has angles whose measures are 65 and 62. So we'll say that's 65 and that's 62. Are they congruent? Well, we have to find what angle C and angle F are before we can determine whether or not these are congruent. So here, I know that angle C plus 59 plus 62 has to be equal to 180, which means then that the measure of angle C is 59 degrees. So that's 59 degrees. And then we need to find the measure of angle F in our second triangle. So F plus 65 plus 62 is 180, which means the measure of angle F is 53 degrees. So if I look at my two triangles here, it looks like I only have one pair of congruent angles. So no, these two are not similar. Next one here, if we know that these proportions are true, LM over PQ equals MN over QR equals LN over PR. Is there a similarity transformation? Well, yes, there is. It looks like this has been both rotated and dilated. So if we know that those three sides are proportional and that it's been rotated and dilated, I can say that these two triangles will be similar. That leads us to the side similarity theorem, which just says if all three sides of one triangle are proportional to all three sides of the other triangle, then the triangles are similar. So if we look back up here, I just needed to be able to show this part. So just showing that can also tell me that the triangles are similar. So let's look here. In triangle ABC, A is 3, B is 4, and C is 6. In triangle DEF, D is 9, E is 12, and F is 18. Is triangle ABC similar to DEF? So let me match up the sides here according to the order that this is in. So we'd have to say AB over DE equals BC over EF equals AC over DF. So if they were similar, that would be true. So let's plug in the numbers and see if it's true. AB is 6, DE is 18, BC is 3, EF is 9, and then AC is 4, and DF is 12. So is that true that they're all similar? Well, if I put that in my calculator, I would get that each of those simplifies to 1/3. Or are those proportional, I should have said. So yes, those three sides are all proportional. So yes, triangle ABC is similar to triangle DEF by side, side, side. Let's look at another one here. Is triangle BAC similar to triangle FDE? If they were similar, BA over FD would have to equal AC over DE, and BC over FE. So is that true? If we plug in our numbers, 10 over 25, 21 over 35, and 15 over 20. So are all of those the same? 10 over 25 simplifies to 0.4. 21 over 35 simplifies to 0.6. At this point, I can stop because those are not the same. If they're not the same, then these are not going to be similar triangles. The last one, though, is equal to 0.75. So this is no, because the sides are not proportional. Saying no would be fine. I'm just letting you know why. We just proved that these triangles are not similar by showing that these sides were not proportional. All right, let's look at one more here. Is ABC similar to DEF? So AB over DE, BC over EF, and AC over DF. So plugging in the numbers is 8 over 4 equal to 10 over 5 and 12 over 6. If I simplify these, they're all equal to 2. So yes, these two triangles are similar by S, S, S. The last one then, side, angle, side, and it has to go in that order. So if an angle of one triangle is congruent to an angle of a second triangle, and the sides that include the two angles are proportional, then the triangles are similar. So if we look here, we can see that angle B and angle E are congruent. So we need to do the side that's on either side of those angles. So AB and DE, and then BC and EF. Notice how it goes in the order: side, and then angle, and then side. Side, and then angle, and then side. If that is true, then the triangles are similar. So let's look at this one. Are these triangles similar? If so, write the similarity statement. I know that these two angles are congruent because those are vertical angles. I'm going to redraw these two triangles just to make it a little bit easier to see how the corresponding sides are lined up. This angle B is in both triangles, and I know that angle B is the same on both. And then if I look at my triangle over here, I know the shorter side goes between A and B, so that's going to be 27, and then this will be E, and that's 36. And then on my other triangle, the shorter side is between B and D, which is 18. And then the longer side is between B and C, which is 24. So now, remember, I'm looking for side, angle, side. I already have the angle, angle B. So now let's look at the sides. Is it true that 27 over 18 is equal to 36 over 24? 27 over 18 is 1.5. 36 over 24 is also 1.5. So we have two proportional sides, and the angle between them is congruent. So yes, triangle ABE is similar to triangle DBC by side, angle, side. Let's look if these two are similar. If so, write the similarity statement. I'm going to redraw this second triangle so that the 50 degrees is corresponding. So angle F is corresponding with angle B. So I see my 50 degrees is in my lower right, so I'm going to put angle F there with 50 degrees. So this is my D, and that side is 8. This is my E, and that side is 16. So again, if I'm looking for SAS, I already know I have the A, so now I have to check to see if the sides are proportional. So is it true that 12 over 8 is equal to 24 over 16? 12 divided by 8 is 1.5. 24 divided by 16 is also 1.5. So yes, these triangles are similar. Triangle ABC is similar to triangle. Make sure, if I look here, I can see that A and D are corresponding. So if I start with A on my first triangle, I need to start with D on my second triangle. F and B are corresponding, and then C and E are corresponding. All right, one more SAS here. Let's redraw our second triangle so it's orientated the same as our first triangle. I know this is going to be my 30 degrees, so that's going to be angle P. This is going to be my angle R then, and this is going to be my angle Q. Between P and Q is 6 centimeters, and between P and R is 7 centimeters. Now that I'm not going to be using that one anymore. So my corresponding sides would be AB and QP, AB over QP, and BC over PR. So let's see if that's true. 3 over 6 and 3.5 over 7. And both of those give me 0.5. So yes, we can say triangle ABC is similar to triangle QRP by SAS. All right, these last sets of examples, we need to figure out which shortcut we can use to show that they're similar or not similar. If I'm looking at this, I see that I'm given 3 sides, which means I'm probably going to check and see if SAS will work. I'm going to redraw my second triangle so it's kind of facing the same way, orientated the same as my first triangle. So I'm going to reflect it, which means now this is G, this is still H, this is F. Between H and F is 14, between H and G is 12, between G and F is 8. So now my proportional sides, AC over HF, AB over HG, and CB over FG. Plugging in the numbers for those, 84 over 14, 72 over 12, and then 48 over 6, over 8. Is it true that all of those are the same? And they are each equal to 6. So yes, I can say these triangles are the same. CBA, I see that C corresponds with F, so I need to start with F here. B corresponds with G, so that comes second. And then A corresponds with H, so that comes third. And they are similar by S, S, S. Let's look at another one here. Again, because these two are vertical angles, I know that they are the same. If I look at my sides here, they're going to be 39 over 16 and 40 over 16. Well, without putting that in my calculator, I already know that those two fractions are not going to be equal. So no, these are not similar. If they were similar, I could have used side angle side, but in order to be similar, this would have to also be 40, or the other 40 would have to be 39. All right, let's look at this one. Again, we have congruent angles there. And if I look at my sides, it would have to be MV over VT and LV over VU. So is it true that 14 over 49 is equal to 8 over 28? 14 over 49 simplifies to 2/7. 8 over 28 also simplifies to 2/7. So these two triangles are similar by SAS. VUT congruent to, if we look here, it goes from V to U. So it's the shorter side between the 49 and 28. That means on my other triangle, I need to go from V to L. So VLM, by side, angle, side. All right, one more here. It looks like I have angle T congruent to angle J and angle U congruent to angle K. So I have two angles of one triangle congruent to two angles of another triangle, which means these are going to be similar. So let's make sure we get them in the right order. Angle J and angle T are the same, so T has to come first. Angle K and angle U are the same, so U comes second, which means V has to come third. And they are similar by angle, angle. All right, friends, have a nice day.